All right, so now we're going to work on finding the derivatives of inverse trig functions. So what that would look like is y equals inverse sine of x, or y equals arc sine of x. They both mean the same thing. And what that says is that y is the angle. So if we think of it on a right triangle, the angle is y, and its sine, opposite over hypotenuse, would be x over 1. So that leaves, by Pythagorean theorem, this side to be c squared minus a squared, or 1 minus x squared. So now we need to figure out how to find the derivative of this guy. So the explicit equation is the y equals inverse sine of x. What we call the implicit equation would be sine of y equals x over 1. So basically, now we're having the sine of y, where usually we have y by itself. So we've already labeled the sides of our triangle. And if we look at this, well, we also could think, okay, can we take the derivative of this now? Because we know how to take the derivative of sine. The derivative of both sides gives us cosine of y, but we want it in terms of x. So this is where we do that funny tag on the dy dx part, equals, well, the derivative of x, that's just 1. So now the derivative means we need to get dy dx by itself. So dy over dx equals 1 over the cosine of y, except that's in terms of y. We don't really want to leave things in terms of y. So we think, okay, what is the cosine of y if we go back to our triangle? So if you had me for geometry, maybe you remember our friend Frank the Bunny. And if you did not have me for geometry, you can ask somebody who did, and they can ask them about Frank the Rabbit. And if you know where Frank the Rabbit comes from, kudos to you. So the cosine of y would be the adjacent square root of 1 minus x squared over the hypotenuse 1. Well, unfortunately, this is 1 over cosine y, which means we need to take the reciprocal of this. So that means dy dx is 1 over the square root of 1 minus x squared. And that is the derivative of inverse sine. Now, we're not going to go through and find a long way of doing the derivatives of all of the inverse trig. So what we'll do is we'll make a list, and then we're going to do a little bit of practice with it. So inverse trig derivatives. So the derivative, if it's y equals sine inverse, and instead of using x, I'm going to use an m, because we're going to have a lot of chain rule with these. It's going to be 1 over the square root of 1 minus m squared. If it's cosine, then think of what we talked about with the regular extra trigs. Anything that starts with a c is going to be negative. So it's negative 1 over 1 minus m square root of 1 minus m squared. Now we work on tangent. 1 over 1 plus m squared. Cotangent. 1 over 1 plus m squared, but it starts with a c, so what happens? We add a negative. Now these you need to memorize. Optional ones, if you're looking for something to do on the weekend, would be inverse of secant, which is 1 over the absolute value of m times the square root of m squared minus 1, and a cosecant, negative 1 over the absolute value of m over square root of m squared minus 1. So again, because it starts with c, it's a negative. So now let's just practice using this. You can always go back and try what we call the triangle method, which is what we did up here. And draw your triangle out and work it backwards. Or you could say, you know what, I'm just going to memorize these formulas and do a little plug and chug style. So, for example, if we want to find the derivative of cosine inverse of the quantity 2x cubed, this is where chain rule is going to come in because we have an inside function. So that's our m is 2x cubed. So that means m prime is 6x squared. Who's the outside? Well, that's our inverse cosine. That's the new guy. What was its derivative? Well, we have to go back to our list because I'm sure we've memorized it already. And here it is, -1 over the square root of 1 minus m squared. So -1 over the square root of 1 minus m squared. And chain rule says multiply these two guys together. So y prime equals m prime 6x squared times this whole guy, which is negative, and then over the square root of 1 minus our m squared. Well, that was 2x cubed squared. So we could simplify this to be -6x squared over the square root of 1 minus 4x to the 6th. And that is our final answer.